16 tells us that we have a page of a book that's supposed to have an area of 90 square inches with 1-inch margins at the bottom and sides. So this measurement right here is 1 inch, along with this measurement from here to here, and this one right here. And the margin at the top is supposed to be 1/2 inch. We're supposed to find the dimensions of the page that will allow the largest printed area. So we're trying to maximize the area of the page. So we're talking about the printed area of the page, so this rectangle on the inside. So if we say this whole page is X, the width down there, and the height is Y, then for the printed part, this section is going to be X minus 1 inch on this side, minus 1 inch on this side, so X minus 2. And then this part of the printed side is going to be Y minus 1 inch down at the bottom and 1/2 inch up top, so Y minus 1.5. Alright, let's say that P equals the printed area. And that's what we're trying to maximize. Well, that area is going to be X minus 2 times Y minus 1.5. We need to figure out something X or Y in terms of the other variable, so we're going to use the area of the whole page. It's 90, so area of the whole page is X times Y. So 90 equals X times Y. Divide both sides by X. Y equals 90 divided by X, or 90 times X to the negative first. We're going to use this to substitute into this equation for Y. So the printed area equals X minus 2 times 90X to the negative first minus 1.5. Now we could take the derivative of how this is right now. We'd have to use the product rule, or we can just go ahead and multiply this out, distribute it using FOIL before we take the derivative. So X times 90, X to the negative 1. We add those exponents, we just get 90 times X to the 0, or just 90. And then minus 1.5x minus 180 times X to the negative first plus 3. Now we can take the derivative of this. Actually, let's stop first before we take the derivative and combine like terms. So, printed area equals negative 1.5x minus 180x to the negative first plus 93. Now if we take the derivative of that, we can go ahead and get the derivative. We get negative 1.5 plus 180 times x to the negative second plus 0. So now we want to know, when is this 0 or undefined? Well, for this, we can rewrite it. We get negative 1.5 plus 180 over x squared. If we add 1.5 to both sides, we get 1.5 equals 180 over x squared. Multiply both sides by x squared. 1.5x squared equals 180. Divide both sides by 1.5, and we get 120. Take the square root of both sides. X is approximately equal to 10.95 inches. This is our only critical value that makes sense, because if we put in 0 for x, that would make this undefined, this derivative. But again, not going to have a width that's 0. So x equals 10.95 inches. And then to find out what y is, we could plug that back into our equation over here. 90 equals x times y, or y equals 90 divided by x. So y equals 90 divided by 10.95, which gives us 8.22 inches.